Okay. Hi everyone. I hope you guys are doing well. Um, so in today's lesson, we are going to look at data transmission media. As you can see here on my presentation. Okay. So what is data transmission media? What do you mean by data transmission media? So basically, data transmission media, we should say it's a way of how you get your data to reach its destination. What do you use? What type of means? What means do you use to get your data to be transmitted from the source to its destination? So how does it reach its destination? Okay, so this is where look at what are possible means, or what can you use to transfer your data from one source to another, or from the source to its destination. Because there's no way that the data can just reach its destination without going via a certain media, okay, without being carried via a certain media. So this is where we need to discuss these different types of transmission media that one can use to get to get his or data transmitted to its destination, or reach its destination. Okay, so we have got two types of them that we'll be discussing. We have got cable transmission. So meaning you can use cables. You can use cables to transmit media, your data from its source or from one node into another. Okay, so one of the media that you can use is cable. Okay, so you need to plug your the certain cable into your PC and into the other person's PC. Okay, so that you can able to transmit data between the two of you, or between the three of you, depending on how many are you on the network. Okay, so cable is one of the media that you can use. Okay, and then we have also, you can also use radio transmission. Okay, radio transmission is one of the way also you can use to get your data get to its destination. So this is one of the transmission media that you can also use, radio transmission. But now with radio transmission, you don't need cables. You don't need cables. Okay, so as long as that you have got a space, okay, this space, and you use certain technologies there, which we'll be discussing as we are going through this presentation. Okay, so these are the two ways you can transmit media. Okay, either using cables or using space or air. Okay, and with radio transmission, you don't need any cables, so it's a wireless transmission. Okay, so the first one is wired, which is cable transmission. The second one is wireless. Okay, so no cables, no whatsoever is needed. Okay, so your signals are just transmitted in the air, or in the airspace. Okay, so and then refer to them as non-conducting what media. Okay, now let's quickly look at the cables transmission. So we are saying cable transmission are type of guided transmission media. They are guided. Okay, cables are usually known to transmit electric energy. Okay, normally we know that we have been told that cables, or we only know that cables are used only for to transmit electric energy. But however, cables when it comes into telecommunications, the cables are used to transmit electromagnetic waves, and they are called what? Electromagnetic wave guides. Okay, so between two nodes, you can put a plug. I mean, you can plug in a cable, or you can put a cable in between two computing devices. Okay, and then you can able to connect this, and by so doing, you can transmit data. Okay, so a cable is one of the it's one you can use to transmit data. Okay, now moving on to radio transmission. In radio transmission, radiating antenna is used to convert a time varying electric current into electromagnetic wave or field, which freely propagates through a non. Okay, so they propagate or they travel through a non-conducting medium such as air. Okay, take an example of an antenna. Okay, so if, let's say it's for radio, you want to listen to a radio. So what you do is, for you to listen to receive the signals or the broadcast, you need to tune into the same frequency as the transmitting antenna. Okay, and in between the antenna and your device, you don't need to have cables. You don't need to connect cables. But as long as that you have the same frequency with the antenna that is transmitting the signals or the frequencies, and your radio. Okay, like if you are in the range of 100 megahertz. Okay, so what you do is you can just tune in your radio on that same frequency. Then you can able to listen to what being said in that channel. Okay, or in that range of frequencies. Okay, so and that it does not require any cables. Okay, it's just the antennas that are actually radiating or transmitting these signals to you, and then for you to receive them or to be on the same channel or same level, you have to tune them, your radio or whatsoever, the same frequency, and then you'll be in the position to watch or listen to what is being said. Okay, so let's move on. Now going on with the cables, because remember we said we have two types of media, either cables or radio transmission. You can either use radio transmission or you can use the cables. Now with cables, when it comes to cables, we've got different types of cables when you're transmitting data. Okay, the first one is copper Ethernet cables, and we have got optic fiber Ethernet cable. So these are the different types of cables that we'll be discussing in today's lesson. Okay, so now let's look at the copper Ethernet cables. So we have got two types of cables that we'll be looking at: the copper Ethernet cables and optic optical fiber Ethernet cables. Okay, now starting off with copper Ethernet cables. So we are going to look at, under Ethernet, copper Ethernet cables, we also have got sub types, okay, subgroups of copper Ethernet cables, and we are going to look at the we are going to look at these types of copper Ethernet cables based on the usage. Okay, we are going to look at them based on the usage, and we are also going to look at them based on physical structure. Okay, and we are going to look at what? At what is the based on the structure, and okay, and then based on the category. Okay, so it's the structure. The first one is going to be structure. No, based on the usage, and based on the physical structure, and based on categories. Okay, so those are under copper Ethernet cables. Now, starting off with the first one, we under copper, based on usage, we are going to discuss the straight through cables. me please. The copper straight-through cables, we have got the crossover Ethernet cables, and we also have got the console cable. Okay, so now, so as I've said, we are going to look at the usage of these cables, or this type of cable of copper Ethernet cables based on the structure. Okay, on the usage. So what do you mean by the usage? So usage, we say the straight-through cables are used to connect these similar devices. All right, these similar devices. It connects these similar devices. Like for example, if you've got a switch and a router, if you want to connect the switch and the router, those are two dissimilar devices. Then you use a straight-through Ethernet cables. Okay, because these devices are not the same; they are dissimilar. Or a switch and a PC. Okay, if you're connecting a switch and a PC, these two cables to use it's a straight-through cable. Or a switch and a server. Okay, so all these to connect these devices together, we use what you call a straight through cable. That's why we said we are going to base these types of cables on their usage. Okay, so a switch, between a switch and a router, between a switch and a PC, between a switch and a server, straight through cables. So it's used to connect this similar. That's a very, very important one. These similar devices, okay? The devices that are not similar in other words. Okay, moving on with the next one, the type of copper cables based on usage. We also have what we call the crossover Ethernet cables. Okay, so now the crossover Ethernet cables, they are opposite to the straight-through cables. So these ones are used to connect similar devices. The crossover Ethernet cables are used to connect similar devices, which, for instance, a switch and a switch, a router and a router, a PC to PCs. Okay, so to do that, to do this connection, if the devices are similar, then you use what we call the crossover Ethernet cable. Okay, so it's used to connect similar devices. Okay, so when you're building up your network on the packet tracer and you're configuring, so remember, make sure that you're using the right cables between certain devices. Okay, so if the devices are not similar, they are dissimilar, then you use the straight-through cable. But if the devices are similar, then you use what you call the crossover Ethernet cables, because it's used to connect similar devices like a switch and a switch, a router and a router, PC and a PC. Okay, and then the last one, based on the usage, still on the usage as well, we are saying we used to connect, we have got a what, we have got a console cable. The console cable used to connect a switch or a router to the PC when doing configuration to a switch or a router. Okay, if you buy a new router or a new switch, and then you want to do configuration. So you can't do configuration like on the router itself without first connecting to the computer and run the commands or make the configuration using the PC. Okay, so you need to connect your switch or the router, your new switch, the Cisco switch, or the Cisco router that you buy to a computer so that you can do the configuration. So now that connection, like a new switch or a new router, you need to connect to the PC and do the configuration, okay? Because the PC, I mean, the router have got what we call a console port, okay? So for the console port, it requires the console cable for you to connect to the PC to do the configuration, okay? So these are the three types of of copper cables based on the usage. We said we have got the straight-through cables that used to connect dissimilar devices. We have got the crossover Ethernet cables that are used to connect similar devices, okay? And then the console cables are used to connect devices to the computer. when you are doing configuration, because you need to connect your switch to a router, or you need to connect a switch to the PC, or the router to the PC to do the configuration. Okay, so you need a console cable. Okay, moving on. Now, the type of copper cables based on the physical structure. Based on physical structure. Okay. So based on the physical structure, we have got the unshielded twisted pair, the UTP, which is the first one here. This is the example of UTP. It's most cable that is used nowadays. Okay. So the UTP is the most widely used cable. Look at the structure of UTP. Look at the structure. It have got so mostly is the one most cable that is used nowadays, and it's used in businesses and in homes. Okay, and it consists of 4 pairs of cables. Okay, so if you look at the cable at this UTP here, you've got the first pair here, and the second one, and the third one, and the fourth one. So it have got what? Consists of 4 pairs of cables. Okay, and these cables are also insulated, right? Right, now the second one, based on the physical structure, is the STP, the shielded twisted pair cable. Okay, so the STP, they are similar to UDP, but it added extra coil. Okay, if you look at these two, I think you should be able to see the difference. You can see, if you look here, if you check on the STP, there is this other coil here. Okay, this layer. Okay, so there's another layer added for security purposes. Okay, you see this thing that is wrapped around them. But if you look at the UTP, it does not have that. Okay, they're more or less the same, but the only difference is that this one have got this. They have added this extra coil here. I mean, this coil shielding or insulating. Okay. And it also have got an extra layer for security used in industrial environment. Okay, so this one is used in industrial environment. Okay, like in industries. Okay, when you're doing some connections or doing some connections in industries, the STP cable, I mean the shielded twisted pair, is the most cable to use in such a scenario. Okay, so moving on. Okay, so we've got UTP, we've got STP under the physical structure, and then now we have got what we call coaxial cable. Okay, so these are the different types of coaxial cable we have. The first one, the coaxial cable, we said it's it contains a metal shielding inside. Okay, if you look here, it have got this little metal here, this little metal inside. Okay, so it contains that metal shielding inside. Okay, and then mostly the coaxial cables are used by TV cable companies to connect satellite antennas to the network. Okay, so it's mostly used in a TV cable company. Okay, to connect satellite antennas to the network. All right. So those are the 3 types of copper Ethernet cables based on the structure, because we basically look at the structure here. Okay. Now let's go and look at the third one, the type of copper cables based on the category or rating. Okay, we have got Cat 5, we have got Cat 5E, Cat 6, Cat 6E, and Cat 7. Okay, so all these cables are used based on their category. Okay, so as they are listed here, they have got a different speed. Okay, they have got different speed. So Cat 5, it may be slower than Cat 5E, and then Cat 5 it's also slower than Cat 6E. Okay, So if you look here, so we have got the Cat5, Cat5, Cat6, Cat6A, and Cat7. So this Cat5, the Cat5 is slower than a Cat7. Okay. So if you opt to go to use Cat5, then definitely the speed of your network is going to be low. Okay, compared to when you use Cat7. Okay. So these are copper cables based on category or rating. Okay, based on their speed. Okay, so meaning the higher you go, the more the speed you get. Okay, so as you're moving from Cat5, Cat6, this is how your speed of the network also increases. But if you move from Cat7 down, that's how the speed also of your network increases. Okay. So moving on to the second type of cable, which is, so the first one, it was copper Ethernet cables. Now we'll be looking at the optical fiber Ethernet cable as a second type of a cable that is used in data transmission. The optical fiber cables contains tiny glass inside an insulating layer, and we have two types of them. Okay, we have got two types of optic fiber cables. Okay, so we have got a single mode fiber. This one is designed for longer distances. Okay, so if you are having, if you want to have to cover long distances, then you should go or opt for the single mode fiber cable. Okay, so it has only one propagation bar. Okay, so if you check here, this is what you could refer to as a propagation bar. It have got only one propagation bar. Okay, it have got only one propagation bar. So people, for this, you just have to understand these basics. We don't need to go that much deep in scrutinizing the differences between all these cables, but just put a bit of just the understanding between these type of cables. Okay, so you said we have got a single mode fiber cables that is designed for longer distances. Okay, so if you're intending to have to go for longer distances, then these are the type of cables that you need to use: the single mode fiber optical or fiber optic, the single mode of fiber cables. Okay, remember we said it has got only one it has got one propagation bar. If you check here, this is our propagation bar. It has only one. Okay, and then the type of the second optical fiber cable is multi-mode. So the multi-mode is designed for shorter distances. So it's opposite to single mode. Single mode, we said, is for for longer distances. So the multi-mode one is for shorter distances. Okay, and it have got several propagation bars. Okay, so if you check here, this is an example of multi-mode fiber cable. As you can see here, it have got different several propagation bars. Okay, here in the middle here, it have got propagation, or have got several propagation bars. Okay, so those are the different type of cables that we have. We have got two types of cables. We have got the Ethernet, the copper Ethernet cables, and secondly, we have got the optical fiber cables. Okay, in the first one, we looked at different types of copper Ethernet cables, where we look at different types of them based on their structure, based on their usage, and based on their categories. And then the second one, the second type of cables is what is referred to as optical fiber cables. And we have got only two types of them. We have got single mode and multi-mode. Okay, multi-mode for shorter distances, and the single mode is for longer distances. Okay, so if you're intending to cover a large distance, then you should go for a single mode fiber cables. Okay. Now that was on cables. That was on cables. Now let's go to transmission, to radio transmission. Okay, as we say that in radio transmission, a radiating antenna, this is what we have said. In a broadcast radio channel, an omnidirectional antenna radiates a transmitted signal over a wide area, over a wide surface area. Okay, so basically what you are saying here is, in this type of transmission, there are antennas that are used to broadcast or to transmit signals over a certain service area. Okay, and as a user, you have to be within the signal area, or you have to be within the area for you to receive the signal. Okay, if you are far, then you won't receive proper signal. Okay, so you have to be closer to the antenna. You have to be closer to the radiating or transmitting antenna for you to receive the signal. So in a point-to-point radio channel, directional transmitting antenna is used to focus a wave in a narrow beam, okay, which is directed toward a single receiver. So in radio transmission, we've got the source or the center, and then we've got the receiver. Okay, so the person that is receiving this signal. Okay, so first the signal is transmitted or it's broadcast. Or it's the signals, it's actually they radiates from its source, and then it travels, it goes to the receiver. So the receiver has to be within the area for him or her to use or to get this signal. If you're far, then you won't get signals, or the signal strength will be really very it will be very low. Okay, and then you have a problem when it comes to connection, when compared to someone who is closer to where the signals are being transmitted from. Okay. Right now, this whole transmission, the radio transmission process, it has got components. Okay. The first one is the transmitter. We have got what you call a transmitter. All right. The transmitter takes some sort of information. It could be bound. It could be the sound of someone's voice, pictures for a TV, data for a radio modem or whatsoever, encode it into a sine wave, okay, and transmit it with the radio waves. Okay, I think this is straightforward. Okay, so the signal is, it can be either, as we said here, the transmitter takes some sort of messages, and these messages can be what? Can be someone's voice, okay, like mine as I'm talking, let's say, for instance, or the picture of a TV set, okay, like when you're watching a TV, where do you think these pictures are coming from? Data for radio modem, okay, like when you're listening to radio, what this whole connection, so how does it happen? So it comes from someone, okay, and then it goes somewhere, okay, and then it encodes into a sine wave. So this is, it's taken by the transmitter, and then it encodes it, okay, and it change it into a sine wave, and this is transmit. This is when all these messages are transmitted. Okay, so and then they use what you call radio waves, okay, to transmit all this. Okay, either being for someone's voice, the picture, or the data for radio. Okay, so all these are encoded into a sine wave, and then this is only transmitted with using radio waves. Okay, and then the receiver receives the radio waves and decodes the message from the sine wave it receives. Okay, so remember we're talking about decode. encode and decodes, okay? Because the message that was sent, it was put in a different format, okay? It was changed into a different format for it to be transmitted. Now, for the receiver to understand what was sent, this information have to be changed to its original message as it was sent, okay? So that is the decoding process, okay? Both the transmitter and the receiver uses antennas to radiate, capture the radio signal. Okay, so both of these are two. They use what you call an antenna. So the transmitter and the receiver have got little things. When you look at the radio, okay, there's an antenna that you pull out for it to receive signals, okay, and even your cell phone also have got an antenna. But I think it's a built-in antenna. You can't see it. But when you look in the olden days, the other cell phone, they were having like an area on top. That is an antenna. So it's using that to listen to receive any signal from the transmitter. Okay, and then the transmitter also have got an antenna for it that helps it to transmit now the signals. So that is one of the component of radio transmission. Okay, we said it's the transmitter. Okay, and then we also have got the receiver. So the receiver also receives the signals. So we've got the transmitter, we have got the receiver. Okay, so if you look at these two examples here, this is a typical baby monitor with the receiver on the left. So the receiver is this one and the transmitter on the right. Okay, so this is the receiver and this is the transmitter. Okay, and it's monitoring the baby in the house. Okay, the transmitter sits in the baby's room. So this is the receiver. I mean the receiver, the transmitter. Sorry, it's in the baby's room, and it's essentially a mini radio station. Okay, the parents carry the transmitter, the receiver, around the house to listen to the baby. Typically, the transmitter distances. Okay, so the whole process here is. So the baby sits with the transmitter, with the receiver. Okay, so we've got the receiver on the left and then the transmitter. So the mother is kind of guiding her child, whatever he's doing. So the transmitter will transmit the signals depending on what the child may be saying. It get recorded and then it's transmitted. Then the mother will be able to listen to what the child is. Maybe the child was crying, maybe he was playing. So all these are recorded and then it's transmitted to the receiver. Okay, so this is one way of guarding maybe your house, or yeah. So you'll be receiving signals on whatever it's happening in your house. Okay, and yeah. So once you have got your own receiver here, then you will be in a position to know what is happening in the room. Okay, because you will be receiving signals from the other side, from the transmitter. Okay, and then the phone. This is the phone. Okay, this is the old phone that we normally use. Okay, they've got an antenna here for an antenna. It contains a transmitter and a receiver. Okay, and both operate simultaneously on different frequencies. Okay. So the cell phone, we are saying it communicates with a cell phone tower and can transmit 2 or 3 miles. Yeah, so the cell phone, it actually transmit or it communicates with the cell phone tower. Yeah, so once transmit, the other one receives. Okay. Right. So I think we can just end here. Lesson, and then we'll continue with the other lesson. Okay. See you soon.